In this video lecture, we're going to discuss regular expression, how to design RE. So let's start with example 1. So we are requested to design a language accepting strings of length exactly 2 from the language A and B. So we could list the accepted string of the language, and from there, we could form the regular expression. Okay, so the language will accept AA, AB, BA, BB. So the regular expression could be represented as AA union with AB, union with BA, union with BB. But unfortunately, this representation of regular expression, or this irregular expression rather, doesn't seem um, reflect the length exactly 2 when you see this regular expression. Okay, so why not manipulate it, rewrite it, apply the identities so that there is a possibility that it will be more representative of our length exactly 2. Okay, so let's manipulate this regular expression. So why not factor A from the first 2 and factor B from the last 2 terms? So it will be A concatenate with A union B union with B concatenate A union with B. And as you can see, A union B is a factor or it is present on the first and the second term. So therefore, we could factor it out. So we have A union with B intersect with A union with B. And as you can see, we have 2 terms here. It means we have 2 symbols in R, okay, in R expression in our language. So the first term represent the first symbol. It could be either A or B. Concatenate with the second symbol. So it could be either A or B. So this is the better regular expression compared with the first regular expression. Okay, because it really represents the length exactly 2. Okay, so this is the better way of representing the language. Okay, A union with B concatenate with A union with B. Okay, so now let's move on with example 2. Now we are requested to create a regular expression that accepts string of length at least 2. So minimum of 2 will be accepted, 2 or more. Okay, so if we're going to relate it with example 1, we only have 2. Okay, 2 terms. Now at least 2, so it means minimum of 2. So if we're going to implement the clean or closure, okay, or clean asterisk, we could have the regular expression for this language. Okay, so just to list ABB, so we can at least all the acceptable strings since it is infinite. Okay, but we could relate it with example 1. So one answer could be, okay, introduce a new term, a third term with asterisk with a clean function. So it means the third symbol could be present and it could be not. Okay, so that's the meaning of this A union with B asterisk. So there definitely we're going to have 2 symbols and the third is optional. Third and succeeding are optional. And another way of representing our language, we could use the plus. Okay, the plus sign. Don't forget, plus sign means excluding epsilon, but everything is included. Okay, so the answer, if you're going to use plus, it will be plus written on the second term. Okay, no need to include the third term. So a plus b plus if you're going to use the plus. Okay, Now, let's move on to example 3. Now, accepting strings of length at most 2. So maximum of 2. So it means from 0, 1, and 2 will be accepted. So it is finite. So we could list all the acceptable strings. So which are epsilon AB, AA, AB, BA, BB. Okay, so epsilon means no string, no length could be accepted by our FSA. Okay, if we're going to relate it with example 1, what will be the adjustment of the equation? What will we going to introduce with the term to have a length of 0, a length of 1, or a length of 2? Okay, so we're going to introduce epsilon on both terms. Okay, so it means epsilon or A or B. Okay, so it could be no symbol here and no symbol here. So it means we have no length of 0, so which is acceptable. Or no symbol on the first, but with a symbol on the second. So length of 1 is accepted. Okay, same as with we have a symbol on the first term, but on the second we don't have, so it's still accepted. And for both, if we have a symbol, it's still accepted. Okay, so this will be our answer. But in case you want to derive it from this list of acceptable string, we need to apply identities. Okay, introduce epsilon redundant term so that we could derive this equation. Okay, so I'm going to introduce epsilon with AB and epsilon. And also, I'm going to have a redundant epsilon A and epsilon B so that it will be used, the redundant term will be used later for the factoring of some variables. Again, epsilon A is just A. Epsilon B and epsilon B is just B. Okay, R is still R, don't forget that. And epsilon is just epsilon. Okay, so now, so we're going to do factoring after introducing epsilon and redundant term. So factor out epsilon with epsilon A, and epsilon B. Okay, so this will be the result. And then factor out A with epsilon A, AA, and AB. This will be the result. And factor out B with 2 epsilon B, BA, BB, and this is the result. As you can see, by introducing epsilon and the redundant term, we have a common term between the 3 terms, which is epsilon union A union B. So now, if you're going to factor it out, this will be the result, which is the same as this equation. Okay, this is acceptable. If you want to have this equation and this solution, again, this is also acceptable. Okay, so this is example 3. Example 4. Write a regular expression for the language accepting all the strings which are starting with 1 and ending with 0. So in this example, it should start with 1, it ends with 0. In between 1 and 0, we don't care. If we have lots of symbols, it could be either or 0 or 1. So if we don't care for the length, if we don't care with the symbol, okay, it means we're going to use the clean, okay, with union. So start with 1 and 0 union with 1 asterisk. It means either 0 or 1. It should be present. It could be present, it could be not. And then followed by 0. So this is example 4. Okay, so that will be my last example. See you on the next video lecture. Thank you.